The next compound or the reagent we are going to see is Umpolungs. Umpolungs is a German word and it shows polarity reversal. That's called polarity reversal. Umpolung means polarity reversal. And it is actually first proposed by the person called Seebach. Seebach. There is a reaction called Cory Seebach reaction. So there will be reversal of polarity actually taking place. I'll give an example for that. You can see that here normally, you can see that here in this case, this is a carbonyl compound. The oxygen is negative charge, carbon is positive charge. So this carbon atom is positively charged. So what happens is that the nucleophiles can attack this carbon atom and use this product. It's a traditional approach that we generally use. But if this carbon atom is negative, okay, then we can see that there will be a change in polarity at the carbon atom. And that is actually called a reversal of polarity. So that is called reversal of polarity, and that is actually what is called an Umpolung. That is called Umpolung. Okay, normally we have got this carbonyl acyl cation, or form a cation. Okay, so generally this is a cation, but if you can make that an anion, there will be an inversion of polarity or inversion of charge. That is actually called polarity inversal or reversal of polarity or Umpolung. So it will give you some very interesting results, interesting synthesis. But you can see that the reversal is not very simple. So we need to do some extra steps to do the synthesis. But the output of the different multiple steps that we do is actually remarkable because it will give you good results, in fact. Okay, now we are going to see the reaction called the Cory Seebach reaction. That will give an example of Umpolung. Okay, this is the next reaction. It's actually called dithiene. This compound on treatment with butyl lithium will give you a system like this. And to this, you can do electrophilic attack and it will give you this compound, this compound. Now we are going to see in detail what is happening here. This is a next reaction, but now we are going to see what is actually happening here. You can see that this is actually the carbonyl compound. Here you can see the carbon atom is positively charged and the oxygen atom is negatively charged. This compound on treatment treated with 1, 2, 3. It is called propane. It's called propane 1,3-dithiol. Okay, what can happen is that the H, the oxygen atom and this H, they can combine together to form water. They give some water. Water is removed off. The reaction will take place in presence of some Lewis acid catalyst. So as a result of that, what happens is that we have got RH here. 2 valencies are free. To one valency, this sulfur attacks, and the second valency, this sulfur attacks, and we will be getting this compound. Okay, it's actually dithiene. It's actually called dithiene. So to this dithiene, if you react butyl lithium is a very strong base. It's a base. Base can abstract proton. Base can abstract proton. So the base, actually what happens is that it will abstract the proton. H+ is going out. Therefore, this carbon atom becomes negatively charged. Okay, so carbon becomes negative, and this butyl lithium is positive always. Butyl lithium is negative, and this negative and this negative and this positive, but we got as butane. So minimum butane is going out. Okay, and what happens? This minus charge and the lithium, and this become minus charge and lithium become positive charge. This is actually what is called a mass acyl anion. It's called a mass acyl anion. You can see that here this carbon atom is negative charge. We started here with a positive charge carbon atom. Now, after reacting with the dithiol and subsequent treatment with the base, what happened is that the polarity become changed or reversed. The carbon atom become negative charge instead of positive charge. It is actually what is called polarity reversal. Now, what happens is that if you treat this with the electrophile, lithium will be replaced by the electrophile. Negative charge, the negative charge gives to electrophile. As a result of that, what happens is that the lithium is replaced by the electrophilic system and this is formed. This system are treated with mercuric oxide in water and THF. Again, what happens is that here there will be water, O is here, okay, and the 2H will be here, this H will be here, and you know what happens is that this R become one oxygen is there, and these two valencies are free. That frequency, the freed valency attacks the oxygen atom, like that will become, and there will be E. Okay, this is the reaction what is happening. Okay, so we can see that here we had a positive charge carbon atom. Now we converted that to a negative charge carbon atom and did the reaction. Okay, generally, you know, if this is the system that we are used, it is actually negative, positive charge, it is actually negative charge. If you replace, treat it by R plus, R dash plus, you know what happens that, or electrophilic system, for example, if you treat this with electrophilic system, it will not attack the carbon atom. Why? Because electrophile is positive charge, this carbon atom is acyl cation is positive charge. So they will not attack, the reaction will not take place. But for that, what we did is that we converted that the positive charge center to a negative charge center and facilitated the reaction. This reaction is called the Cory-Seebach reaction. So there is polarity reversal. There will be inversion of polarity here. And that is actually what is called Umpolung. It is actually what we refer to by Umpolung. So this mass acyl cation anion is actually an Umpolung. This reaction is called the Cory-Seebach reaction. This polarity inversal or charge inversion is called Umpolung formation. Now we are going to see different examples or different applications. So you can see that here this is our formaldehyde, is HCHO, formaldehyde plus dithione, SH dithiol, I mean, SH. It forms, the O is there, O and the two hydrogen will go in presence of Lewis acid. It forms CHH, and you know here there will be sulfur, and here there will be dithione formation. This is dithione. Okay. Now what happens is that this compound on treatment with butyl lithium, one H is replaced by lithium. So this forms a lithium salt. So this we can react with an alkyl halide. Alkyl halide will be having plus charge and minus charge here. This plus minus will attack this plus, and you know it will be got as minus. And now what happens is that it becomes this system, and this on treatment with HGO and HgCl2 to give an aldehyde. So formaldehyde can be converted to a higher aldehyde by converting that as an Umpolung. Now we have got this dithione. Again, this dithione, if you got another equivalence of butyl lithium and THF at minus 25 degrees Celsius, what happens is that again another Umpolung is formed. We can add another this thing, and you can see that there will be a ketone is formed. So again we can convert. For one equivalent of butyl lithium, we will be getting this thing, and R dash Br will be getting this. And if we have got formaldehyde, and if there are two equivalents of butyl lithium and two equivalents of alkyl bromide, we will be getting a ketone. So this method can be used for the synthesis of higher aldehydes and ketones from simple aldehydes. So it is having a lot of other application. This is again an aldehyde. It is actually a dithione. This butyl lithium, it forms salt. It's clear. It's what forms salt. Salt is something like this. Carbon atom is minus charge. This is the alkyl we started with, this salt. To this, we can see that another aldehyde reacts. It reacts like this. I will show the reaction like this. You know, I will show this reaction now. this is what is happening. Okay, plus this is the ketone that I'm going to use. This is a minus. This minus will attack here and will be attacking here. The lithium, of course. This will react and okay. So as a result of that, there will be O minus and O minus, there will be Li plus. This compound don't return with HGO. Okay, what happens? You have seen that there will be reduction. HGO and water. No, hydrolysis, not reduction. HGO and water will give you this get here is sulfur and this whole sulfur is there. Okay, so what happens is that this will be going out as thiol and it hydrolyzes, this become a ketonic part and here it become, here there will be, this will be OH is formed. Okay, this is formed. It's actually a alpha hydroxy ketone or acyl oil. So alpha hydroxy ketone or acyl oil. Similarly, it can also react with benzyl bromide. You can see that here the benzyl bromide will be attacking this side and it will be attacking that side, and it can form a higher ketone. Now this is an epoxide. This can get an epoxide. This is the, I'll write like this. Minus and Li plus. The epoxide, we can write the epoxide like that. This is epoxide, phenyl epoxide. This minus can attack the carbon atom, this carbon atom or this carbon atom. But this carbon atom is circularly hindered, so it will not attack here, but it will attack this center and the bond is broken and like this. That leads to the formation of this system. And there will be, okay, O minus will be there. Sorry. It's not O minus. So this is the first carbon atom and this is the second carbon atom. Okay, this is the first carbon atom. Here will be O minus. The O minus lithium will become O minus lithium plus. And here there is second LBPH. This compound not repellent with HGO and water. If that become hydrolyzed, as a result of that, we'll be getting R, double bond O. Here will be OH and here it's pH. Okay, so it is alpha and beta. It's actually a beta hydroxy ketone. So to the Umpolung, if you use an epoxide, it will give you a beta hydroxy ketone. If you use another ketone, it will give you alpha hydroxy ketone. And if you use some compound, depending upon the nature of the compound, will get substituted compounds. These are some of the very important reactions of Umpolungs and applications of Umpolungs. Shall see more applications in the next slide. See the applications. So this is the Umpolung here, and this Umpolung is formed as a result of the reaction between this aldehyde and thiol. It forms butyl lithium with THF, and this compound, after it will react with different substrate. You can guess different substrate and you can understand the reaction that is happening. And after that, it is reacted with HGO and water. So the different products are obtained. And kindly please go through them and find the answer, how you got this. These are some of the applications of Umpolungs. So Umpolungs are synthetically very applicable compounds. They can be used to make compounds that is not easy to synthesize otherwise. So always remember that Umpolung formation means charge reversal. Here you can see it is minus and lithium is plus. Earlier it is actually plus charge. This is a plus charge system because it originates from this system. Carbon is plus charge, but by we are converting that to another charge. Plus is converted to minus. There is reversal of polarity happening here. This is called the polarity reversal of Umpolung formation. So again, we have got other examples also. This example 1, 2 additions. I kindly go through these examples and see some of them are repetitions, but we can see that kindly go through them and see how it's happening. It's actually an ester. We treat with the format ester, it will give 1,2-diketone. Similar ester, other esters will give again, it will give is actually formal ketone. So it is CHO and CO, 1,2-diketone. The 1,2-substitute diketone is formed like that. You can please go through them and find it how it's happening. That's all about the Umpolung reactions. So Umpolungs means polarity reversal or reverse polarity or change polarity. So thank you very much.